Okay, for 77, they're asking us to solve the system of equations algebraically. So let's just let's drag this over here, make it a little bigger. Okay, so here's the system, right? It's two equations. There's a lot of different ways we've learned to do this. We could use elimination, we could use substitution, we could even graph them and look at it, but clearly we don't want to graph in this case. I would look at this and say it's really easy to solve this bottom equation for one of the variables and substitute. That would be my inclination in this one. So I'm going to do that. So I'm going to rewrite this system. I'm going to leave the top one the same, 2x minus 3y equals 12. And I'm going to subtract x from both sides on the bottom, so it becomes y equals negative x minus 9. Now I'm going to use substitution. I'm going to take this negative x minus 9 and I'm going to substitute it in the top equation for the y. So I get 2x, the top equation, minus 3 times what I'm substituting in, minus x minus 9, equals 12. And now I'll distribute the negative 3 in. So it's 2x. Negative 3 times negative x is plus 3x. Negative 3 times negative 9 is plus 27. Equals 12. And we combine our like terms. 2x and 3x is 5x plus 27 equals 12. And we subtract 27 from both sides. So 5x equals, and 12 minus 27 is negative 15. And then we divide both sides by 5 and we get x equals negative 3. And we're not done. Don't box that and move on. We're halfway done. We solved for x. And now I'm going to take that and I'm going to put it into this bottom equation because that's the easiest. So y equals negative 3, right? It's negative x, which is negative 3, minus 9. So y equals 3 minus 9, y equals negative 6. So the answer is the ordered pair negative 3, negative 6. Remember, when we solve a system of linear equations, we're looking for the point of intersection. So we always give the answer as an ordered pair. And in this case, the ordered pair is negative 3, negative 6.